Good morning, guys. So while we're waiting, I would like to give you back this screen. Can you see that? So this one, you have to refer to this diagram, and before we start the lesson, the questions on last night is that we would have delta H of neutralization, right, with a definition, which is you are going to produce 1 mole of water from the neutralization reaction. Okay, so this is the definition. So the focus is on the per 1 mole of. So 1 mole of water, if we focus on the product water, the neutralization product to consider. So that's why you will see this HCl, NaOH, NaCl, H2O. Well, for 1 mole of water to be formed, it is minus 57.1 kilojoule per mole. For different types of acid, just like HCl, HNO3, in case we react with any which type of strong alkaline, and they will react to form a very similar data, minus 57.2 kilojoule per mole. So minus sign here means what? It means it gives out heat. It gives out heat, okay? Exothermic reaction. So at the same time, you will see this information. We have got methane acid and NaOH to form sodium ethanoate. Now, this one you need to show the sign here, right? So it is not purely organic, okay? We have got organic salt, so it's not just got all those covalent bonds. We have got ionic bond in between the two species and 1 mole of H2O. So, but the neutralization is minus 55.2 kilojoule per mole. Why? Okay, so this is what I would like to show it last night. Anyone who can have a factual recall, right, after several hours of sleep, could you still remember what is the reason why this data is less negative? Okay, the magnitude is smaller while it's keep it as negative. Do you still remember what's that? Okay, shall I call upon Wu Gaolong? Morning.
因为 because it needs energy to break the bond.
Yes, energy to break the bond. Which bond?
OH.
OH bond. Okay, OH bond. So what is that process? What we call that? What is the process? Why do we need to break that bond, OH bond, but not other bond? You don't know?
Ionize.
Ionization, right? It's a type of ionization of acid. Okay, so this is what's the behavior of the acid. Once I dissolve in water, it will ionize. Okay, for this part. So needed for the ionization with acid. So the equation will be CH3COOH AQ reversible sign H plus plus CH3COO minus. Do you still remember? Okay, this one you talk about ionization. While this one in particular, you are going to break the bond here, so it will require energy. So that's why even though the reaction will release heat, part of it will be used mainly for breaking down those OH bonds. Do you understand? So for the other cases, just like this one, this is the questions I leave you last night. Okay, ethanoic acid plus ammonia to form ammonium, ethanoate, and water. Do you know what is the enthalpy change of neutralization of this, and why? Can you predict? Ladies and gentlemen, can you predict? Hello, ladies and gentlemen. Breakfast. Hi. So could you please answer why? So what is that data? neutralization or for this reaction? Is it the same as this, minus 55.2, the same as minus 57.102, or maybe less negative or more negative? Do you understand? Less negative than this one, okay, minus 55.2, okay, so even less negative than 55.2 kilojoule. So the reason, what do you think would be the reason? Okay, anyone who can help for the reason? Trần Xuân Thanh. Okay, that's true that this one is less negative. Less negative than minus 55.2 kilojoule per mole. I will show you on the web. Enthalpy standard, enthalpy change of neutralization. I will search it on web. I'll try to search it all together with you. Neutralization. So what will we get? We've got some data like this. Now, could you please, okay, could you please capture this for your further use? Okay. So this is what you may know about this one. Tell me why. So what I want to tell you is this. The question is why? You may see this diagram. Tell me why. Why is that such a difference in the data?
因為佢啲 energy 攞咗去 ionize 嗰啲藥酸。
How about this case? Now, this one, I just asked you guys to think of this case, right? The last case, methanoic acid react with ammonia. Both they are weak acid and a base, so it will give you a even less negative value. Now, so when you compare with this, minus 57 point something, it just dropped to 50.4 only. Why? It's not just ionization for this, right? It's not just ionization for this, but also this ionization. Can you get my point? So how do I know? So the product for this it is CH3, COO minus, NH4 plus. Okay. So for this process, both process will involve the ionization. Can you get the point? So this one also undergo ionization. Ammonia also undergo ionization, so it needs energy. So so as that of the weak acid. So that's why. So you may find that for these cases, just like if the acid is weak acid, strong alkaline, or strong alkaline weak acid, you may find those data less negative than minus 57.1. Okay, so while you would, it seems like you split these two into halves. So you may find that minus 57.1 or 2 is something as standard data. How do I know? How do I know? It seems like reference data. So no matter what acid do we have, Okay, as long as it's a strong acid, and we together with the combination of strong alkali, they would react to form water and salt. So yes, that's right. So I think it has got the point. So the ionic equation is the same. The Ionic equation is the reaction between hydrogen ion and hydroxide ion molecules. While these two, right, this part, the acid fully ionized in water, while the alkaline is fully dissociated in water to form ions. So once it dissolves in water, the hydrogen ions and hydroxide ions, the quantity of them would be much related to how many moles of acid and alkaline has been added. Okay, so no mixture and no any energy consumption for the ionization or dissociation. So in the solution, we have got 3 hydrogen ions and hydroxide ion to react together will form 1 mole of water. Okay, so that's why, yeah, if you have this, you still have minus 57.1, irrespective of the different acids of that, as long as they are strong acid. Okay, can you get my point? So can you predict the case when you have, for example, HCl and KOH? So what will be the delta H of neutralization of this? If I change this one, alkyne, into KOH, can you guess? Hello, Manhei, are you here? Yeah. Can you guess the data? You may choose the data on the right-hand side. Okay, which one? Which one we think? You don't know. So anyone who can help, I give you some multiple choice questions. First of all, A, minus 57.1 kilojoule per mole. B, less negative than minus 7.1 kilojoule. C, more negative. Okay, anyone who can help? A, B, C. I think you mentioned it as minus 57.1. Hey, A. About the others? Dong Jinglam, what do you think? A, B, or C? A. A. Yes, the answer is A. Okay, why? We still talk about what? A same strength of acid and alkaline, right? We talk about strong acid, strong alkaline. And the ionic equation is still the same. Hydrogen ion react with hydroxide ion to form 1 mole of water. So the answer is still A. Okay, can you get a point? A. So the answer for this is minus 57.1 kilojoule per mole. Understand? Now, I'll give you one more chance. Now, what will happen if I talk about this one? So what is the delta H of the neutralization for this case? Now, you know that it is a strong acid, strong alkaline combination. So what is that? What is this one? Now I will give you these example right on the top. Some choices this time. I know that more negative. Most of you will not choose this. Okay. How about this? How about this? I would like to choose this one. The third one is minus 1, 1, okay, 4.2 kilojoule per mole. Okay, what do you think about this? My question is, maybe any question, anything that you want to ask before you come up with A, B, or C. So the question is, now anyone, all of you think that this question is clear? It's very, very clear. What is the delta H of neutralization of this reaction? Now the question is, what is the delta H of neutralization for this reaction? Do you understand? So, 正為 row 呢就 C， 長順係 A， 溫字為 A， 質地陣結 C。Limiting, of course, basicity. Yes, it's rather confusing. So that's why I asked you this question. So what does mean by neutralization, delta H of neutralization reaction? You have to go back to the definition, right? You have to go back to the definition. The definition is the delta H of the reaction is the enthalpy change when an acid reacts with an alkali to form 1 mole of water under standard condition. Okay, so some keywords, 1 mole of water. So it really depends on what equation you are going to talk about. So can you tell me the equation for this reaction? If you do not write down the equation, we cannot continue, right? Can you get my point? If you do not write down anything about the equation, what is the equation? Yes, I know it is strong acid, strong alkaline, but what is the equation? The equation is what? Half, yeah, to form You mean this? You mean this? Yeah. So if you want to talk about this, the delta H of neutralization, it is what? It is still the same as minus 57.1. Okay, can you get a point? But if you want to talk about this reaction, actually, Mr. Chi, I want to fully balance the equation like this using simplest whole number ratio. Now, so this is our proper way of write down the equation, right? So you are going to list H2O here. So if that is the case, the delta H, for this part, it is not delta H of neutralization. It's just delta H of reaction for this. Okay, can you get the point? So delta H of neutralization for this, so for the second equation is just delta of reaction, which is exactly minus 114 point something kilojoule per mole. Of course, the data will not be absolute. There will be a slight change, a slight difference when you talk about this, but you may see that it's just a multiple of the first equation. Okay, can you get the point? So what is the hidden message? You are going to be very aware of the following two. One is the strength of acid and alkaline. Okay, in order to come up with the data, how much energy will be released. Okay, and two, you are going to talk about per mole of water form while you compare the heat released in this reaction. Is that clear? Okay. Can you get a point? For those who can get what I mean, could you please put up your hand? Just let me know if you understand. Just one. Gallon, let's see why. Yes, that's right. Good. Easy. So remember, you need to consider the two before you proceed. So it seems that you guys, you just want to have more consolidation, right, of this topic, because it seems that you're not so energetic while you compare with studying organic chemistry too, right? So I do think it would be good to have a consolidation. I don't want to start something new. Okay, instead I just try to take with some some of the questions. Okay, such that you know what is that. Especially for getting to know those neutralization, formation, combustion, right? Because last night it's just you just get to know what is that, but once you go into practice, you still don't know what's that. Okay, so shall we go over to the MCs? Take a look. MCs, which is on this page. Okay, so there's the one which is circled in green. I just highlighted in green. That is what you have to attempt, which means all questions. Except question 11. Question 11, I still haven't talked about it, so leave it later. Now spend some time on it now. Question 2. Now you have to take out a book. Besides, you have to take out your calculator to come up with the questions. How would you get the answer? A hot tub contains this gram of water. Well, very similar to physics, right? Very like, it seems like physics questions. So what is the amount of heat required to warm the water from this to this? So the amount that, if you want to talk about amount of heat required, so the amount of heat required, yes, that's right. So you are going to find out amount of heat required. So what equation do we need to have? Is equal to mc delta T. Required means absorb, right? So that's why the delta T is just the large number minus the small number, right? So the water, the mass of water is 1.20 times 10 to the power 6 gram. For mc, it is what? Just copy 4.18 joule per gram per Kelvin. So what's more is about the delta T. Delta T is 40 minus 22, which is 18 Kelvin. So you may get the answer. It is 9.03 times 10 to the power 7. The unit is now joule. Okay. So how you know the unit? Okay, I cross the unit. So you may find that. So leaving behind is just joule. Okay, so the answer is B. So remember, the first one I would like to talk to you is on the equation, MC delta T, this one, okay, MC delta T. Easy start. And how about question 3? The standard enthalpy change of combustion of ethanol is this. 153 kilojoule of heat are released, okay, give out heat. When a sample of ethanol is burned under standard conditions, what is the mass of ethanol burned? So you are going to come up with the number of moles of the ethanol to be burned. So when compared with this and this, so you may know the number of, what is the data? It's just less, okay, it's just less. So how many times less? Is it just 1 mole? No, so you are going to come up with the number of moles. The first thing is you are going to find out the number of moles of ethanol burned. Which is equal to 1,368 kilojoule per mole. So you may find this. So it's just for 1 mole. So you are going to put it into denominator. So you such that you can come up with the number of moles of ethanol. 1,368 kilojoule per mole. And we have got 153 kilojoule. So what will we get? What will we get? What is the number of moles? .112, okay? 0.112 mole. So which means for this reaction, is just react with 0.112 mole of ethanol. So you're going to come up with mass. So what does mean by that? You're going to find out the mass of ethanol burned, which is just what? Number of moles of ethanol times molar mass of ethanol, which is equal to 0.112 mole times ethanol. The C for this one, the molar mass, it is 46.0 gram per mole. So you will get the answer. It is 5.14 gram. Can you get a point? So the answer is D. Question? No? If not, take a look on D. D. The specific capacity of some metal are given below. Which one? Well, physics. It is a physics question, isn't it? Again, physics question. Which of the metals will have the smallest temperature change? If you are going to give you the same amount of heat to heat this. So which is the which will show the smallest temperature change? Which one? So yes, that's why B. So no need to calculate. No need to calculate. Why do you know? Because H is equal to MC delta T. In case it is the same, in case this is the same, okay, so you are going to find out this one. You are going to look for the delta T, which is the smallest. So what is the hidden message about C and delta T in this reaction? C and delta T it is in inverse proportion. So you are going to find out C, which is the largest such that you can make it smallest. Can you get a point? So indeed, for those they are to do the same, which means that delta T and C, they are in what? Inverse proportion. Okay, inverse proportion. Can you still remember what's that? It seems like today we are now teaching you mathematics, okay? Inverse proportion. You understand? So that's why you are going to find out which one is the smallest temperature change. You are going to look for the largest specific capacity. Understand? Okay, if not, if no questions, we'll come up with question 5. A cold pack for heat treating sports injury. So you may see the word cold pack. Underline the word cold pack. Sports injuries will make ammonium nitrate and water are kept in different chambers. When the pack is needed, the chambers are broken and ammonium nitrate dissolved in the water. The dissolving process is A, B, C, or D. 朱俊輝 Can Zhu Junfei and Lei Hinlong, could you please give your answer? What is that? Question 5. A, B, C, or D? Hello? Breakfast? Or just slept? Not here? Some of you will say that D. How about you, Lei Hinlong? What do you think? And Zhu Junfei? How about you? What do you think? I try to find some other people, right? They'll be on the bottom of the list. That is from Cyrus, 徐家榮, 李卓俊, 余日斌, 余志豪, okay? For those. Get prepared for the questions. C. No, it's not C. It's not C. No. So D is D. So what is that? Cold pack. So cold pack. You have got sports injury. First of all, it is something common sense. Sports injury. What does it mean by that? You make it hurt. You have got maybe you twist the ankle. For example, what you are going to do is to cool down. Is to cool down the affected area quickly. So you know that if your joint is swollen, it will get inflammation. Okay, it will get swollen very quickly. Lei Tong, good morning. It's now 9:08. You are late. Now, so the cold patch. So you are going to have a cooling of the affected area as quickly as possible. So the sports injury, we have got that to ammonium nitrate and water. So indeed, you may find that Mr. Chin is very, very strange, right? This part, the salt, while dissolved in water, it will be cooler. Okay, it will be cooler. So cooler, which means it takes in heat. Yes, that's right. You know it is takes in heat. But what is that? The process is endothermic. So which means that we have got the system here, right? We have got the surroundings. The surrounding is about here. Okay, we've got that one. We've got the surroundings. The surroundings. So your hand is just part of the surroundings. You touch it. You touch it, and you feel cool, right? So what does it mean by that? Of course, the system inside it is the cold pad. The cold pad that would absorb your heat. Okay, the heat will be absorbed through here. Can you get the point? Heat will be absorbed through this. So the endothermic process, positive delta H. Only by this part you are going to raise the enthalpy level of the system up to higher, so positive delta H. So endothermic process, what is that? From the reactant to the product, we have got the positive delta H. Is that clear? So you may find that the solution of a substance is endothermic. Is this statement correct? Leighton, tell me, is this statement correct? That the solution of a substance, of any substance, is endothermic? It's not reaction, it's an endothermic process. Agree? No? Counter example, please. So that is what the question is asking, right? Yu Zihou. How would the question be changed to have delta, negative delta H? Yes, I change what? I change the salts. If I change the salts, they will have a delta H being negative, which means it will release heat. Can you please give example? Some examples of this. So the answer is no. Some examples. Yes, very good. Calcium oxide. Once react with water, it is exothermic. What else? It's not just calcium oxide, but indeed it's not a dissolution. It is a formation of what? It is a formation of some other new substance. It's not dissolution. It's just a reaction. It's a reaction. Can you get the point? We will not have any calcium oxide AQ. Is that, what is that? We have got calcium hydroxide. Slack line. If you don't understand what is that, go back to our YouTube. You go to Form 3 IS and you will know what's that. What else? Dissolution. Which means I dissolve in water to form the same substance, right? But it's solution. No? Leighton, give me example instead of just telling me no. Cyrus 魏卓賢 calcium carbonate. Who taught you Form 3 IS? Calcium carbonate is water soluble.魏卓賢 Samson Lee, calcium carbonate. I ask you, is it water soluble? So how come you just say that no? You better say sorry to the Form 3 IS teacher, simply because you forgot all the things. Now, how about 魏卓賢? No. What is mean by no? Can you give me some example? No. Samson, do you know what do you know about caustic soda? Caustic soda. What is that? What is caustic soda? So do you know what's that? Baking soda? Huh. Caustic soda is not equal to baking soda. So baking soda can be eaten. Help. You should have withdrawn from studying chemistry, Samson. Or even though you have to take a supplementary lessons on common sense. It's a common knowledge. Caustic soda, it is NaOH. While baking soda is NaHCO3. So that each serve different purpose. Tell me, what is the use of caustic soda of NaOH? What is the use? Well, what is the use of baking soda? If you say a baking soda, which means it can be eaten, right? Caustic soda cannot be eaten. Oh, of course you can eat. Or if you eat it, what will happen? Your throat will be burnt by those chemicals. What is the use of these two? Samson, tell me. Or manufacture of what? Paper, NaOH, yes, that's right. What else? NaOH is used to make paper. What else? What's the use of caustic soda? Actually, in kitchen, you use it. Huh? You say that it cannot be eaten, but you use it in kitchen. Yeah. But not, of course, not in the cooking pot. What is the use of NaOH in kitchen? Detergent, something like that. But not actually, it's not a detergent. It is used to what? Clean, or if you use of the drainage pipe cleaner. Okay, especially in case the drainage pipe has been blocked by oil, I use NaOH. So how would you buy this? You don't know what's that? You go to the Untitled and you may get a bottle like this. Okay, with a white bottle on the red cap. Okay, it will buy you $10 for 3 bottles. So it is used to you are going to use it as a drainage pipe cleaner, especially you have to deal with the oil blockage. Okay, you use this. So what is the chemistry behind? How come I use NaOH and I put it into oil and it can clear or the blockage? Cyrus, do you know? Any Cyrus can help? Huh? You don't know. Who's Isaac? Who's Isaac? This guy. Who is Isaac? Hey, tell me. Hi, all of you are gone. You don't know. It is something about organic chemistry. Oil, what is that? Yes, emulsification. How come it's emulsified? Before emulsify this, you don't have any detergent. Emulsification is the second step. So far, it's the first step. The first step is what? I do the oil, I have alkaline, so what is that reaction? Yes, very good. Once you have finally, that is only you can get the answers. We call that saponification. Saponification and then emulsification. That follow. The first step, it is a chemical change, while the second step, emulsification, is just a breaking down of oil into droplets. Okay. Can you get a point? Saponification means I would have NaOH will flush with part of the oil, okay, that will temporarily form soap. Can you get a point? While you have got soap, I need to tell you how you can clean the drainage pipe. Once I spray into those drainage pipe cleaner, so you have to stay for some time. Let's say 15 minutes. So what's next? Do you know what's next? You're going to pour some hot water into the pipe. So can you think of the whole procedure, right? First of all, I need some time for alkaline hydrolysis of the oil, cooking oil. And next, while I need to flush it with hot water, is to get some part of the oil which has been saponified, it will form soap already. I flush with hot water, so I give you some energy, some action to it, such that it will do something like a cleaning inside the pipe. Can you get a point? So what is the baking soda? Baking soda, it is used for what? You don't know? Once I heat it, they will form this. Okay, they will form this. So what is that? Because of CO2, it is a good chemical to replace yeast. Okay, it is a yeast substitute. How more? Do you know what's that? It is used for what? Baking, right? What's what we mean by baking? I need to make a bread dough. Okay, I need to make a bread dough and add baking soda into it. Once I bake it, so the this one sodium pentothioate will decompose under heat to form CO2. It will give you a bread, a spongy feeling, spongy. The bread will become spongy. You don't understand. It is something not only about chemistry, but also biology, but also daily life. I can do nothing but sigh. Question 6. Consider the following combinations about this. Relative stability of a reactant product, the sign of delta H is correct. C? Yeah, correct. No need to further explain, right? It's easy. So what's next? For the other questions, I would not go over with that. Instead, I would like to, let me see, because time is running short. I just have 3 minutes left. Take a look on question 12. Take a look on question 12. Do you understand how about this one, question 12? When 10 cm cube of 2 molar HCl react with 10 cm cube of 2 molar NaOH, the temperature change is this. What is the temperature change? C. Some of you say the C. Why? If you see this one, it is very similar to exam questions, right? Very similar. Very similar. So the question is, we have got 10 cm cube, 2 molar HCl react with 10 cm cube, 2 molar NaOH. It is delta T. Okay? So what the reaction is repeated using 10 or 20 cm cube of 1 molar of HCl and 10 cm cube 1 molar NaOH. What is the temperature change? Okay, so you may find that confusing, but if you want to take a look on these two, you may find it very strange. It's because of you may say A. Some of you say A. Some of you say C. What is the difference? What is the difference between the two? We have got two cases. The first case, 10 cm cube 2 molar. Okay, HCl plus 10 cm cube 2 molar NaOH. The second case, it is 20 cm cube 1 molar HCl and 20 cm cube 1 molar NaOH. Can you get a point? We have got two cases. So what is the number of moles of water to be formed? What's the number of moles of water formed? it is 0.02. The same, right? The same. Okay, but yes, that is what I would like to say. So the heat released, if you say that H, this one is also H, the same. But the mass of the solution change or not? So that is a question. Tell me what is the mass of the solution mixture? What is the mass of solution mixture? If you say that this one, it is about 20. 10 plus 10, it is 20. About 20.0 gram. About. Because I don't know anything about density. Okay, it's 10 cm cube, 10 cm cube. It's about 20 cm cube for solution. Okay, how about this? Similarly, it's about 40 cm cube solution. If I treat this, the density of a solution is the same as water. It is just a multiple of 2 for the second case. So what will happen to the delta H? Delta T, okay, delta T. In case we have got 1 delta T, how about this? It will drop to T half. Why? We have got H is equal to what? MC delta T. Again, just like what I've just said in the last case, H is something we are going to release the same amount of heat because I produce the same amount of water. Okay, so but for this part, it is double. So this, if you treat this the same, so what will happen is to make this data what? Half, such that it can be still the same. Can you get the point? It is something about this. You have to get to know the concept of physics as well. But don't worry, if you don't understand about physics, once you will see our graph, the table here, you can get what I mean. It is something about the way to relate to two. Questions? Questions? You find it difficult? I just do half of the MCs here. You find it difficult? Now I'll try to stop here, and tonight we will continue. Any questions? Now, so what did I say today, this morning? Not much. We just tell something more about the cases. On the delta H of neutralization, I give you this diagram, right? I just give you this diagram for further analysis. I would like to talk to you about the different scenarios, different combinations of acids we have with alkali. So it will give you different types of delta H of neutralization. So the underlying principle is very simple. You are going to deal with 1 mole of water to be formed by the combination of hydrogen ion and hydroxide ion. But not all cases will release all hydrogen ions or hydroxide ion respectively. So it really depends on the strength of acid and alkali. So if the acid or alkali, they are both strong, okay, so they will, and irrespective of the nature of the acid and alkali, they will release the same amount of heat. But if you change the strength of acid or alkali, just like this case, the first case is weak acid, strong alkali, the reaction is less exothermic. And similarly, if you have a strong acid, weak alkali, it is also less negative than minus 57.1 kilojoule per mole. Whereas still, if I both change the acid and alkali into weak one, then they will make the delta H of neutralization even less negative. The reason behind is about the energy consumption in ionization of acid and alkali, especially while they are weak. Okay? Second, if you want to talk about this equation, you are going to delta H neutralization, irrespective of basicity of an acid, you still take a look at the work per mole of water produced. So if I ask you this question, what is the delta H of neutralization? The answer is still the same, minus 57.1. However, once I change this, the first equation, the second equation, and make it multiple by 2, it is the normal way while you do the balance equation. The delta H is not delta neutralization, it's delta reaction. It is minus 114, which is just the double of this one in mole ratio times 2. Can you get a point? So because of this, I would go to the question here, right, to come up with the relationship MC delta T. Okay, you may get this, or to have a consolidation, you have to calculate MC delta T. You have to get to know something about concept of MC delta T here, right? Can you see that? Such that you will know the relationship between the two. Okay, so for sometimes I will keep those parameters, some of the parameters the same, and I ask you what is the change of the others. Okay, you see that you may see number 4, you may see number 12. It tells you the similar concept. Can you see that? Anyway, I will use the same equation. H is equal to MC delta T, and I keep those some of the parameters the same. And I ask you what would be the change of the others. Can you see? Very, very similar. Don't worry too much about the, what type of reaction, what type of questions they are asking, but the underlying principle, they are the same. Okay? Do you have any questions so far? No? If no response, already all gone away, or all be frightened away because of something about mathematics. But don't worry, there will be more to come. Okay, for the remaining blocks, 3C, 4A, and 4B, all those, they are just calculations. So you have to get used to that feeling. All right, so I just stop it here. Tonight, I will try to see you guys tonight. Goodbye.